Section 4.4 is about trig functions of any angle. So our goals for the day. We're going to define trig functions of any angle. That's probably obvious based on the title of this section. We're going to evaluate sine, cosine, tangent if we're given a point on the terminal side of an angle. And we're also going to calculate these things called reference angles. So in general, to find the value of a trig function for any angle, you simply need to know where the angle is in the coordinate plane. Remember SOHCAHTOA, and you're good to go. Let's take a look at a specific, let me clear that out. You didn't see that. Let's take a look at some specific examples. So let theta be an angle in standard position with x, y, a point on the terminal side of angle theta. And the radius r is equal to the square root of x squared plus y squared. So if you were to make this into like a right triangle here, this would be a triangle with side lengths of y and x here. We got a right angle here. Now the sine of theta, now this is our angle, which is related to this angle. The sine is going to be the opposite over the adjacent side. The opposite is going to be y over the adjacent side of this length here. Oh, we already had it labeled there, of r. The cosine is going to be the adjacent side, x over r. And the hypotenuse, goodness gracious, the tangent is going to be the opposite over the adjacent, y over x. For cotangent, that's just the reciprocal of tangent, so that's going to be x over y. Secant is the reciprocal of cosine. This is in a weird order, but it's going to be r over x. And cosecant is the reciprocal of sine, so it's going to be r over y. It's just kind of working your way backwards. So like the first and the last, the second and the second to last, etc. So with this in mind, I want us to pay attention to a couple details. So to help us find different angles and values, or to keep different angles and values straight, it's going to be advantageous to help us know some simple properties, and we're going to use them on this paper here. Using the graph on the left to fill in the positive or negative values on the right. So the sines in quadrant 1 are positive. The cosines are also positive. The tangent, well, tangent is sine over cosine, so they're also going to be positive. The sine values in quadrant 2, those are the y values, so those are positive. The cosines in quadrant 2 are going to be negative, the x values. The tangents are going to be sine over cosine, so it's going to be positive or negative, so it's going to be negative. In quadrant 3, both the x's and the y's are negative, so sine is negative because it's the y, cosine is negative because it's the x. Now tangent is y over x, or in other words, sine over cosine, so it's going to be negative divided by a negative, which gives you a positive tangent. In quadrant 4, the sines are the y values, so they're negative in quadrant 4. Cosines are the x values, so those are positive. And then the tangent is y over x, or sine over cosine, so negative over a positive giving you negative there as well. We're going to try to express a couple of points below. Find the sine, cosine, and tangent of an angle if we know the points on their terminal side. And it says it may be helpful to draw a picture, and by it may be, I mean it'll be very helpful. So if we have the coordinate 5, negative 2, so we're going to go 1, 2, 3, 4, 5 to the right, and then 2 down. Let me put a point there. And there it is. There's our point, 5, negative 2. We're asked to find the sine, cosine, and tangent of this, or the side formed by that. So there's the angle. And we're talking about specifically this angle right here to be formed by the positive x-axis and that ray there, or that segment there. The first thing we need to figure out is the r value. So r is equal to the square root of x squared plus y squared. It's going to be 5 squared plus negative 2 squared. Well, 5 squared is 25, so we got 25 plus negative 2 squared is 4. So we have the square root of 29. Now, that's not the prettiest number you'll ever see, but that's okay. Square root of 29 is a very real number that we're going to use. The sine is, based on what we see above, the y value divided by, started saying y and I wrote y. The sine of whatever angle we're talking about here, again, we're talking about this angle right here, is the y value, in this case, negative 2, divided by our radius, which is, in this case, the square root of 29. Now, just like we've done in the past, we don't want to keep an irrational number in our denominator, so we're going to multiply numerator and denominator by the square root of 29. So we're going to multiply by that goofy-looking version of the number 1. So in our numerator, negative 2 times the square root of 29 is negative 2 square roots of 29, over root 29 times root 29 is just 29. Now, before we go any further, we drew that picture. That's in quadrant 4. Quadrant 4 should have a sine, according to this graph that we had up here, that's a negative value. It is. We got negative 2 times the square root of 29 over 29. The cosine is going to be the x value over the y. Sorry, the x value over the radius. So cosine is equal to our x value of 5 divided by the square root of 29. Folks, the more you get familiar with these, the more you're going to be able to just kind of make the jump to this next part. I'm going to say it's 5 times the square root of 29 over 29. Keep it simple. You're going to multiply both sides by root 29. Things are going to cancel out nicely. The last one, tangent. That one's actually going to be our easiest. I don't know why I switched colors, but you know what? Let's deal with it. It's the y value divided by the x value. So we got negative 2 over 5. And so those are our sine, cosine, and tangents for those points. Let's try letter B together as well. Letter B, we've got the coordinates 1, 3. So let's quickly draw a rough sketch of this. So 1, 3. Here's our point. And the angle we're making there is this angle here. So again, that's just a point on, I'm having a hard time drawing that line. It's a point on the terminal side. It doesn't mean it's the end of the terminal side. Like on the previous example, I probably should have indicated that this point keeps, or that segment can keep going. It's a ray that goes on forever. And it shares, or its initial side is the positive x-axis. So same thing on this one. We're just trying to figure out what this mystery angle is, or what the sine, cosine, and tangent of that mystery angle is. So our sine of whatever the angle is the y value divided by the r value. So it's 3 divided by, well, let's figure out the r value. Remember, r equals the square root of x squared, so 1 squared, plus our y value squared, 3 squared. So we have the square root of 1 plus 9, which is the square root of 10. So for the sine, we have 3 over the square root of 10. Now, just like we did in the previous one, we multiply the numerator and denominator by the square root of 10. We get 3 root 10 over 10. Cosine is the x value divided by the radius. So that we got 1 divided by square root of 10. Multiplying numerator and denominator by square root of 10, we get root 10 over 10. And the tangent is just the y value divided by the x value, 3 over 1. Folks, on the next page, there is one more example that I'd like you to pause and take a moment, draw the picture, figure out the radius, and find the sine, cosine, and tangent. And clearly you've paused it, so let's take a look at our work here. So again, starting off with our r value, the radius, if we were to draw a circle out of this, it'd be negative 7 squared plus negative 4 squared, the square root of all that. Negative 7 squared is 49. Negative 4 squared is 16, so we have the square root of 49 plus 16, which gives us the square root of 65. So for our sine value, we got the sine of whatever our angle measure is here, is our y value, negative 4, over our radius of the square root of 65. And again, we'd multiply the numerator and denominator by that square root of 65, and we end up with negative 4 times the square root of 65 over, that's a weird looking 5, over 65. Cosine is going to be the y value, negative 7, sorry, the x value, I misspoke. I wrote the right value, but I misspoke. So negative 7 over the square root of 65, which gives us, after we multiply by root 65 on both sides, we end up with negative 7 times the square root of 65 over 65. Tangent, this one's the nice easy one. Take your y value, negative 4, divided by your x value of negative 7. We end up with positive 4/7. Now this one I didn't draw a picture, but let's just double check, make sure we're working in the right area. So negative 4, negative 7. That's, negative 7, negative 4. I'm having a hard time. That's 7 to the left. 1, 2, 3, 4, 5, 6, 7, and 4 down. So our point would be right there. So the sine and cosine should both be negative, and again, in quadrant 3, the tangent would be positive.